Hello, GM. Hello, Hawks, and welcome to this ZKsync Era CodeHawks kickoff. My name is Kira Nightingale, and I am a software engineer and instructor here at Cyfrin. And today we are going to be running through the ZKsync Era competitive audit that is currently live on CodeHawks. Before we hand over to our wonderful guests, I'm just going to go through a few quick housekeeping highlights that I want to mention. Of course, this contest is currently live and will be running until the 2nd of December at noon UTC. The number of Solidity lines of code is 15,741. So this is a pretty big boy. And you'll be competing for a prize pool with a grand total of $500,000, which is split into 475,000 for mediums and highs and 25,000 for lows. I also just want to give a very quick overview of the project. Of course, we'll be going into more detail shortly, but ZKsync Era is an EVM-compatible Layer 2 rollup that uses ZK proofs to scale Ethereum without compromising security or decentralization. And all the information about this project, so like the actors involved, the scope, the compatibilities, etc., are detailed in the README on the GitHub, linked on the CodeHawks competitive competition page. And as always, if you have any questions during this stream, then feel free to drop them in the chats in the comment section. And if you have any questions afterwards and you're like, oh, I wish I'd asked that during, then just post them in the Cyfrin Discord or also the ZKsync Discord if you would like. And now I'm going to pass over to our guests to explain to you a little bit more about the project. So we have Stas and Vlad from Matter Labs. Hello, Stas and Vlad, the floor is now yours. Feel free to introduce yourself and share screen afterwards and explain a little bit more about how this works. Let me just change the orientation so we can see everyone. Hello.
Hi, everyone. I'm Stas. I am protocol engineer at Matter Labs. And Vlad?
Yeah, hi, everyone. I'm Vlad, security engineer at Matter Labs. We're working with Stas for more than 4 years already, I guess, on the contracts and stuff for ZKsync.
Okay, so I'll give you an introduction to our Era contracts repository, which contains most of the logic about our system. Let me just share my screen. Okay, so once you open our repository, probably the first thing which you should do is to go to Era contracts docs readme.md, and there you will find the entire documentation for our new version. So the audit is done not for the current version that is on mainnet or even on testnet. This version is in works, so it's been audited before the release. Here in README, there is documentation about all the parts. I will probably not go into deep detail about each part, since each documentation explains it perfectly, but I will mainly focus on how things stick together and where to find the files in general. Okay. Firstly, there is also potential reading order, which you can take. You can choose, so for instance, there is a path which can be used by someone who would rather use our bridging, maybe for what would our L2 developers use. In case of this particular contest, probably the best approach is to actually go read through all the docs one by one in this linear line. And even if you see that some parts are intertwined, some parts require next steps, just don't worry, continue reading. And at the end, you will have a holistic picture of everything. And then you can, when you take a look at a specific contract or you're interested in specific functionality, you can go back to the original documentation and get the detail that you need. So in our repo, there are multiple folders with contracts. Firstly, let's start with L1 contracts folder. The name is a little bit historical, so it does not only contain contracts which are deployed to layer 1, but usually files from there were only deployed on layer 1, but in this specific release, due to some unification of logic, which I'll talk a little bit about later, now it has files which are deployed both on L1 and on L2. So we go to L1 contracts, to contracts folder, and the first thing which you can go in is state transition. There we explain the code and logic which is responsible for a single ZK chain. ZKsync Era is an example of such a ZK chain, but there are more, and more partners get added to our ecosystem. So it grows, and each partner gets themselves a chain, which is represented. Each chain itself is a single diamond proxy, and it points to the following facets. So these hold the logic. Also, this folder also contains files which are needed during initialization of chain. So this is diamond init, which is used during initialization. And also, there is also Genesis upgrade, which is called during Genesis of a chain. You can read more about it in the corresponding documentation. These old chains, they have all separate state, they have all separate admins, but we do not allow them to have any upgrade which they want, because it could allow them breaking ecosystem invariants. That's why we have chain type manager. If someone has reviewed ZKsync codebase before, it was called state transition manager. Now it has been renamed for more clarity. And this contract serves as two things. First is factory for contracts, and B, it is main point through which it is controlled that all chains are up to date, and also all new protocol upgrades are passed through this contract. And that's pretty much it. There are also verifier, which is responsible for just verification of zero-knowledge proof. There is validator time lock, which is just a time lock mechanism to ensure that there is some distance between when batch is proposed on layer 1 and when it's executed in case there is a bug. But all these contracts can be found in docs, settlement contracts, and ZK chain basics. Also, our chains, they accept transactions from layer 1. So users, if they want to call a layer 2 contract from layer 1, they can do so. And more logical how it's done can be read in the priority queue part. So firstly, which is worth reading, is processing of L1 to operations. But in this particular release, we also introduced a new way how the transactions which come from L1 are packed. And this new way is explained in a different file. So don't worry, you don't have to remember the files. All of them are linked in the order to read in the README file, and just saying that they exist. Okay, so after we figured out where we can find contracts for individual chain and the manager of chains, there is also topic of bridging. There is this bridge hub contract, which is the main point where all the ecosystem comes together. So it contains mapping from chain ID to chain type manager, which it belongs to. It also has a mapping from chain ID to their address. All new chains are created through this file. So I said that chain type manager is a factory, but the actual creation starts here. Someone posted a message? Oh, no, I misheard. Okay. And it is the main entry point for doing transactions on the layer 2. So when users want to start a transaction on a ZK chain, they go to Bridge Hub, tell which chain they want to call their transaction to, and that's it. And it will route to the corresponding ZK chain. This functionality is pretty much the same as in the previous versions, if you know how the previous versions work, but it's not needed for the audit, but just in case. And I think from the basic Bridge Hub perspective, that's it. Then now here comes the big changes which came compared to the previous version. It's how we do bridging. So before, basically, whenever you want to bridge a token, you would have to use our default layer 1 shared bridge. And it will only allow you bridging only tokens which are like standard ERC20, that is no special functionality, like wrapped ETH wasn't possible. So just plain bridging of some very plain ERC20 assets was possible. And in case someone wants to have some more functionality, they would have to develop their own bridge. However, the problem here is that typically these user-built bridges, they would share a lot in common. Like, for example, logic in case the deposit fails and allow users to recover funds. There is a lot of repeated logic between different bridges. And generally, to make so what was decided is that instead of having a bridge which is responsible for tokens, what we will do is that we will have two types of contracts. One is asset routers, which are trusted, centralized contracts that are, by centralized, it means that we have only one asset router per chain, like one asset router on layer 1, and on each individual chain, there will be deployed exactly one L2 asset router. And whenever there is a bridging that is done, the communication is only done between these asset routers. However, the exact token handling has been delegated from this asset router to separate type of contracts, which is called asset handler. And users can now implement only their own asset handlers if they want to have any custom functionality. And here in our bridge, you can see that we have L1 asset router, which is deployed on layer 1, L2 asset router, which is deployed on all ZK chains. Like this contract is deployed on all ZK chains, and all bridge communication is done between these two contracts. And as an example of an asset handler, which could be developed, is native token vault. So this native token vault, it represents totally the same functionality as we had before for ERC20 tokens. That is just a simple ERC20 is escrowed on chain 1, and then its copy is deployed on chain 2. That is, its wrapped version is deployed on chain 2. And yeah, so it just simplifies the interface for the users in case they want to have any sort of custom token functionality. You can read more about it, again, in the README, in the bridging topic. Here, in the description about asset router and bridge hub. I think with regards to bridging, that's about it. Now, another thing which was added compared to the previous release is support of custom data availability. So before, chains had only two choices. Either data is rollup, or either chain is a rollup, or chain is a validium, and validium means that data is just not sent. And there was no option to easily add some custom DA validation like Celestia or some other DA validator. And but to allow adding custom DA validation, or maybe allow even adding some custom compression for contracts, we added a pair of contracts for each L2 chain, and one is deployed on L2 and one is deployed on layer 1. And the contract on L2 would be responsible for compressing the data, and the contract on L1 would be responsible for verifying that the data is correct. And our contracts, which are deployed on layer 1, these are in the DA contracts folder. And the contracts for data availability that are deployed on layer 2 side of things, they are in L2 contracts folder in data availability. You can read more about how exactly this DA scheme works in documentation. There will be settlement contracts, data availability, and yeah. and read in the order which is provided in the README. That's one thing. And the other feature that was added is the ability to have another L2 as a settlement layer. So typically, rollups, they settle on layer 1. They send their batch hashes and then send their proofs on layer 1. But but it has certain limitations. It means that, for instance, such settlements cannot happen often. Otherwise, the cost for running the rollup, or just general cost for users, would increase too much. And for the future, we would want to allow to have smaller batches and just to allow quicker exchange of information between different rollups. And for that, chains can use a new settlement layer called gateway. Gateway is just a normal ZK chain. It's totally normal, but it just has to be widely set as a settlement layer. But all the contracts which I mentioned before in state transition, these are all totally applied to it as well. But now an admin of a chain, if it wants to stop settling on layer 1 and start settling on gateway, it will have to bridge its chain on top of gateway. And the logic for this can be seen in the gateway part of the README, and here you can read just how general it would work. But overall, chain migration would work the following way: that the admin calls bridge hub, and then via standard process where only one asset router and two asset routers can communicate, the chain would be deployed. So you can imagine that a chain is sort of an NFT. So obviously it's not an NFT, but when the migration is done, very similar logic is used to it, and it allows to reuse a lot of logic which is common for bridging and for migration. For instance, if migration fails, then very similar method can be used for recovering the chain. Okay, and that's pretty much it on the side of the main functionality. There are also added some new contracts, like for instance L1 nullifier. It will be a nullifier for whatever messages are sent from layer 2 to layer 1. It's the new contract which the old L1 shared bridge has been upgraded to. But about all these other minor contracts, you can read in the documentation. I think it will be fine. Another thing which was added is we amended chain admin contract. It was amended to have a more modular architecture. So before, we had chain admin as basically a non-nullable contract, and then there's also a separate role for calling token multiplier. It's helpful for chains which have ERC20 token to update the ratio between ETH price and their token price, so that users could pay the right price for transactions which come from layer 1. And we thought how we could make it more generic and generally allow any sort of restriction which can be put on top of chain admin. Maybe at some point, some chain would decide that, okay, we want our chain admin to never be able to set any transaction filter, for instance. So that we want our chain to always be permissionless at any, in perpetuity. And our new chain admin infrastructure allows it. So chain admin contains a list of restrictions, and before each transaction, each restriction would be checked. You can read more about it in our chain management and admin role file. But this new chain admin structure is a little bit unstable because there was some issues found with it. So we may not eventually use or recommend to use our partners to use it, but it depends on the eventual decision. So we'll see how it goes. That's it from L1 contracts. And why I said that L1 contracts can compile both for L1 and for L2 is because since we allow new settlement layer, it means that our chain, when it moves to new settlement layer, it will have to use new contracts on top of it. And these new contracts are compiled for Era VM environment. And that's why for L1 contracts, we made sure that they're compilable both in Era VM and EVM environment. And DA contracts are those which are only on layer 1 because there's some feature which is available only on layer 1, and it is blobs. So Rollup DA verification, which uses blobs, is only available for EVM environment, and that's why we could not put it together with the rest of the system. Okay, that's how contracts on layer 1 look like, and bridging contracts look like, and also DA contracts look like. But our system, each layer 2, also has a set of pre-deployed contracts, and some of them have system powers which are needed to either control things like how the default account should behave like, or facilitate deployment of contracts, or check that only bytecodes which are known can be used for new contracts, etc. And all this logic is located in the system contracts folder. So you can generally assume that all the contracts which are present here are the ones which are only deployed on layer 2, and they're typically all pre-deployed. So there are, and the pre-deployment constants can be seen here. So we can see the addresses to where these are pre-deployed. Some of these contracts which are listed here, they're not present. So for instance, message route, it's contract which is attached to Bridge Hub, but it's still pre-deployed for all new chains because we basically, it was just easier this way to ensure that gateway does not have some fundamental differences from any other ZK chain. Okay, so in system contracts, we have two folders, bootloader. This is the main entry point of our ZK VM. So our proof, it actually does not check some transactions per se. It checks that execution of bootloader was correct. How it translates into our blockchain, which we can see from the user's perspective, it can be all read in the L2 system contracts folder from the docs. And here are the contracts themselves. I don't think I can add much about them. Each of these have some system functionality, and they're all pre-deployed. In the documentation, you can read documentation for each individual contract. Also, last final note, which is how did we manage the upgrade for Gateway? So Gateway introduced a lot of new things, like new way of bridging, also the fact that chains now have rather complex pre-deployed contracts, such as Bridge Hub and Message Route. This will be pre-deployed on each L2 chains. And because of that, and to make the upgrade secure so that the admins, they cannot violate the will of the decentralized governance, we had to create a multiple step upgrade process, and it is mentioned here. So here you can read generally which functionality was added compared to the previous upgrade. That's one thing, but with regards to upgrade process, it is itself here. So it would be very good. Sorry. So it would be very good if those who audit, they should also take into account files which are included here, and generally the process itself. We have tested it locally, but maybe something was missed, or maybe there are some ways into the ways how chain admin could exploit this upgrade process. And that's it. So if you are auditing, don't only look at the contracts once they are deployed, but also ensure that the upgrade process itself is safe. And I think that's about it with regards to our big repo. It indeed does have a lot of code, but we hope that documentation covers all of it. Also, here we mentioned some of the tricky places where there could be issues. Obviously, since we listed them here, there are probably we have already thought about these places, but maybe we forgot something. And yeah, that's it from the side of Era contracts repo. Vlad, I think I will give you the.
Sure. Yeah, sorry, had a problem with my internet or something, so I was disconnected, but now I'm here. There's two more topics that I want to talk about. It's not about only Era contract change that we had, but also we had the excitement, a huge upgrade on the governance part, and we switched from the multi-sig upgrades to the decentralized governance. That is a process with 3 different bodies that will lead the upgrades and also the token and the upgradability we are voting. So let me share the screen in a second. Cool. Can you see my screen? I guess yes. Cool. So beside Era contracts, we also include ZK governance contract. That is a separate repo. And you can find README for the ZK governance in the folder of ZK governance. There's not much info, but you can find how to compile and test contracts. And more importantly, if you would want to go to the documentation, you could go to zknation.com and find the documentation about the governance process itself. That contains the token implementation, all the tokenomics information as well, but also the process for the governance upgrades. So it includes different parts starting from the Era contracts that currently deployed and the voting on layer 2 and layer 1 parts for the upgrades. Let's take a look into code. So from layer 2 contracts, we have in scope the governor contracts. There's 3 different governor contracts. That one for ZK protocol governor. This is the most important protocol governor, and this is the contract that is Open Zeppelin based governor contract. So the way it will work is that anyone with enough tokens inside enough delegated token can vote on the proposal and create any proposal that will be executed from layer 2 ZK protocol governor. All the parameters are enshrined in the configuration of the contract. And then after 7 days, the proposal will be created, it will start the voting process. The voting process will also take another 7 days. And after that, there will be execution of the proposal. So this is the protocol governor, the same way we have ZK token governor and ZK GovOps governor. They have pretty similar configuration parts, but the different meaning for the system. So for ZK GovOps governor, it's a governor that will control the non-enforced proposal, basically anything that Matter Labs team or ZK association should do, but not enforce it on the protocol level, on the contract side, anything that should not be upgraded, but more like an off-chain proposal that should be executed. The kind of proposals that we would like to go through the GovOps process is a proposal to give some tokens to some entity or to force Matter Labs to act in some specific way, including some changes to the front end and etc. While ZK protocol governor is much more powerful, it will actually lead to changes in the infrastructure, in the contract side, in the upgradability parts. And token governor is needed only to mint new tokens or to distribute already minted tokens. While the process for the voting is very similar, and you could find all the parameters for the governors in the ZK Nation documentation. Right, as well as you can find ZK token. There's two different versions of ZK token. It's upgradable contract. It's all deployed on layer 2. More specifically, it's deployed on ZKsync Era, and it's already live. So you can check the deployed version as well and see the differences between current and previous upgrade. On the implementation part of ZK token, you can find ERC20 token with a very, I would say, standard implementation with some extensions for minter role, burner role, so that's the roles that can add new tokens to the system, burn already existing tokens. And we have the management for the tokenomics that we have. So only specific addresses with minter roles, in our case, it will be ZK token governor. It will be able to mint new tokens. As well as we added one method for delegation via AP 1271 signatures, but this is more specific to ZKsync account abstraction support. So you would want to support account abstraction with delegation instead of just having standard EOA that supports that. Right, and so for all the voting and all the token transferring is happening on ZKsync Era, but the contracts are governed from the layer 1. And in order to change something on layer 1, we need to pass data from layer 2 to layer 1 somehow, and on layer 1, we need to accept these upgrades. Because of this, we not only include layer 2 contracts, but layer 1 contracts that will actually read the data from layer 2 of what voting was done and what was executed on layer 2 about any decision from the governance, and then execute the upgrade. So you can find the folder for layer 1 contracts. And this is a couple of contracts. This is really important. This is probably the most dangerous part of the system because it controls the upgradability. If a bug is found here, then anyone who would be able to exploit it can make malicious upgrade and steal funds from the system or override anything. And what we currently have is a main contract protocol upgrade handler. I would start from that. You can find the doc comments here on the contract, so it will explain what exactly happening in the system. So token holders on layer 2 propose the upgrade, sends the message to layer 1, and then there's a process for accepting the upgrade, starting from the approval from different bodies, then to execution. And so for the contract, you can see the configuration parameter. It's immutable. It's constant on the system. So we can assess on these parameters as well and look into the actual state transition machine that this upgradability will work for. So the first function will be start upgrade. The way how it works, it accepts all the meta parameters on which layer 2 batch number, what proposal was created, and etc. for proof of the message that was sent from layer 2 to layer 1. And it verifies that proof was sent indeed. It was correctly executed, and the governance on layer 2, voters, delegates, they voted on something and executed the upgrade on layer 2 from protocol governor on layer 2. Then we check that it successfully was proven on layer 2, and we start the upgrade. The upgrade started with a 3-day veto period when Guardian can extend the veto period for another 4 days, so 7 days in totals. But in case it's not extended, veto period will pass, and then we go to another stage of the upgrade. On the other stage of the upgrade, we have two different parties that can vote on the upgrade, the Security Council and Guardians. For approving upgrades from Security Council and Guardians, and it's basically accepts the ID of the upgrade, so the hash of the proposal, and then checking the state of the upgrade, and then approve it. So we go to the next stage of the upgradability. We can find guardians.sol and security council.sol is a contract that is responsible for this multi-sig, so specific parties that can approve the upgrade and move the upgrade to the next stage. And after all the approvals that will happen on the system, this execute function where anyone or the specific party that was specified in the proposal of the upgrade on the very, very beginning of the upgrade can execute it. After the execution, we mark it as executed and then basically execute the calls from the governors. This contract protocol upgrade handler will hold all the permissions to layer 1 and layer 2 chains. So in case of layer 1, it will be able to execute the upgrade on the proxy. It will be able to change the system parameters, and you can find the connection for the layer 1 contracts in Era contracts. So to put an example here on layer 1 contracts, we'll jump to Bridge Hub. And Bridge Hub is a contract that is deployed in transparent upgradable proxy. And the owner of this transparent upgradable proxy will be a protocol upgrade handler from ZK governors. The similar way it works for all the contracts for the Bridge Hub, native token vault, and etc. And this way we can execute upgrades on layer 1 contracts. For layer 2 contracts, we also keep the upgradability from protocol upgrade handler, but in this case, we will need to use layer 1 to layer 2 communication and send the transaction to layer 2, wait for the execution, and then the protocol upgrade handler that is deployed on layer 1 can do the changes on layer 2 parts as well. Right, and then also very important to say is that besides the token voting process with the token holders and security council or guardians that can approve the upgrade, we have emergency upgrade process as well. For emergency upgrade process, it will require 3 different bodies to accept the upgrade. In our case, it's an emergency upgrade board that contains security council, guardians, and ZK association multi-sigs, and altogether 3 out of 3 can execute the upgrade from this contract immediately without any delay. It's specifically designed for fixing security issues on the mainnet, but the Security Council is an independent party that includes 12 different members from different organizations, including security-related company, like audit company, or people who do the other security-related work. And they deeply understand what the upgrade is specified for and what it does indeed. So they need to sign the upgrade. There's a different party for the Guardian that more on the ZK Nation documentations.
Oh, sorry, Vlad, you just froze for like 20 seconds. Would you be able to go back like 20 seconds worth?
Oh, I'm sorry. Okay, so
No problem.
so it's an execute emergency upgrade. I would continue from this part. Basically, what I said is that execute emergency upgrade works in a way that 3 different parties can sign on the upgrade. It includes Security Council, Guardians, and ZK Association multisig. And if 3 agreed on the upgrades, it can execute anything just without any delay. And Security Council is a multisig. It will be threshold of there's different threshold, but there's 12 members, and in order to execute emergency upgrade, there will be 9 out of 12 that need to sign on that. As well, you can find all the threshold in the contract of emergency upgrade board. Right. So it proceeds with the Guardian signatures, Security Council signatures, ZK Foundation signatures, verifies that it's all correct, and then execute emergency upgrade on the protocol upgrade handlers that change make any external call basically to what is specified on the proposal. So it's a security related features to execute upgrade without any delays in case something is found on the system that need to be upgraded very fast. But it requires a high threshold from 3 different bodies. And usually it won't be used for normal protocol upgrades, but rather for anything that need to be fixed fast. Right, and we have other contracts here as well. So it's Guardians contracts. It's a custom multi-sig implementation that basically have 8 members. It's hard-coded in the system. So it's a different a bit from safe implementation because it has only specified actions that can be executed from this multi-sig, and also have a specified targets to which it can be executed. Let's put an example here. In the multi-sig for the Guardians, we have a function Guardians that accepts some signers list, signatures, ID. It checks the signatures, it checks that signers list is correct, and then do the action for protocol upgrade handler to approve upgrade Guardians with the parameter that was specified. So it's kind of hard-coded set of actions to the multi-sig. And for the multi-sig implementation, we use multi-sig contracts that check the signatures. It can check it in 2 different ways, check for ECDC signatures on EOA accounts or for AP 1271 on nested safe contracts or any other specific implementation. But usually we just use safe, and you can also double check with the actual set of signers because it's already deployed on mainnet and see how it's configured. Right, and I think that's mostly it for Security Council and Guardians. Maybe one feature that we also need to mention is the freezability. So for the Security Council, it would be able to freeze all the chain, all the ecosystem of contracts on layer 1, and also all the state transitions that could happen and be approved to layer 1. It's a function for soft freeze and hard freeze. The difference is that soft freeze, it's a short period of time with a low threshold of the signers. For Security Council, it can freeze the chain for a limited time, and then hard freeze will extend the freeze time for longer. And basically, after the hard freeze happen, nothing can work on layer 1 contracts. So there's a set of actions that someone would try to call, but then it will just fail. So it will reverse the transaction. Right. And with each emergency upgrade, the unfreeze would be called and the contracts will remain to be the same on the same state as it was before the freeze. There's also functions to unfreeze the chain in case 7 days period would pass on the extended period of freezability, or if its freezability is just ends. Yes, and would be happy to answer on any questions at this point.
There are no questions in the chat at the moment. I'll just give it like a minute or so, just in case there are people who want to drop their questions now. But that was very informative. Thank you very much. There's a lot to go through there, so you both did a good job of going through all of it in rapid time as well. Just leave it a little longer, just in case if anyone else has a question. They're madly typing away right now.
So what I would also recommend for this audit is to compare the results that we had from previous audit contest and also see the audit results that we had with external audit companies, see the difference between what code was deployed on mainnet for a long time and find the places that was specifically developed in the last month or two. This would be very helpful. Pay attention to the bootloader code, please. We had really good findings there and unique finding, I would say. All the code that is related to gateway is also very, very new and I would say rather complex. So it probably makes sense to pay attention to that as well. Governance is a dangerous place, but yeah, definitely many things to consider. So good luck with audit here.
Great advice. Thank you so much. And everyone, as always, all the information that you will need is going to be on the GitHub repo, linked on the CodeHawks landing page. And again, if you have any more questions that you didn't think to put in the chat now and you have later, then you can drop them in the Cyfrin Discord. A massive thank you to both Stas and Vlad. Amazing job, both of you. And thank you, CodeHawk. Thank you, Hawks, for joining GM and GN. Bye-bye.